Hello everyone, this is Teacher Harold, your junior high school mathematics teacher. And in this video, I will discuss how to solve problems involving variations. And we will begin with the first kind, and that is direct variations. Now, after you watch this video, you should be able to solve problems about variations and demonstrate positivity in doing the assigned tasks for better output. Now let us go straight to some illustrative examples. Again, I'll be discussing the first kind of variation, and that is the direct variations. Or the problem, these examples are all about direct variations. Particularly, let us begin with the direct linear variation. Number one, if y is directly proportional to x and y is equal to 21 when x is equal to 7, so these are the initial values of x and y, we are asked to find the following. The constant of variation denoted by k. Then we must also form the equation of variation and the final value of y when the final value of x is 10. Now, for our solution in number 1, let us consider answering first letter A. But first, let us try to translate this particular statement right here, which is y is directly proportional to x. Now, since this is under the direct linear variation, the translation of this statement using k as the constant of variation would be y equals kx. And from this equation, we can transform it, solving for k, and the equation becomes k is equal to y over x. So it's just a matter of cross multiplication in order to isolate k from this equation. And this is the result. And using this resulting equation, which is already solved for k, we can now find for its value using the initial values of y and x. So using this equation, k equals y over x, and also the initial values of y and x, which are what? 21 and 7 respectively. We plug in these values to this equation. Thus, the value of k becomes 21 over 7, or that is equal to 3. So this is your answer to letter A. And next, for letter B, we are now going to form the equation of variation. So, we go back to this translated equation, y is equal to kx, which is this one. And we rewrite this equation, but this time we're going to replace k by its obtained value, which is 3. So that the answer to letter B would be y is equal to 3x. And this is the equation of variation. Now for letter C, which is finding the final value of y when the final value of x is 10, we just simply use the equation of variation that we have just formed for letter B. In letter B, we use that equation and we plug in the value of x from this equation in order to solve for the required unknown. And that is y becomes 3 times x, which is 10, which is taken from this value, and the value of y would be 30. Okay? So this is the solution for example number 1. Now let us go to example number 2, which is still under the direct linear variation. If P is directly proportional to Q and P is initially equal to 1/2, when Q is initially equal to 2/3, find the following. The constant of variation K, the value of that, and afterwards we form the equation of variation and the final value of Q when the final value of P is equal to 15. So for our solution in number 2, let us translate this statement. P is directly proportional to Q. This is also the same as P varies directly as Q. So if we translate that statement using K, that would be P is equal to KQ. And from this equation, we can solve for K. So that the transformed equation will now become K is equal to P over Q. You just simply do the cross multiplication wherein K here is to be isolated and Q will be placed under P. Kaya naging ganito, P over Q. Next, using that formed equation, solving for K, we use the initial values of P and Q to solve for the value of K. That will be P is 1/2 while Q is 2/3. So you plug in these two values to this equation and simplify the right side in order to determine the value of K. Yun. K is equal to 1/2 divided by 2/3. Recall how to simplify or divide fraction by another fraction and you will get the value of K, which is 3/4. And upon getting the value of K, the next step is to form the equation of variation. So again, we go back to this translated equation, but this time, if we want to copy this, we replace K by its obtained value, which is 3/4. Okay, so aside from this translated equation, we consider the obtained value of K, which is 3/4, and we substitute 3/4 to this equation in order to get the required equation of variation, and that would be P is equal to 3/4 of Q. And from that formed equation in letter B, we can now solve for the final value of Q when the final value of P is equal to 15. So, we make use of this equation. Kinopya lang natin. This one. But your Q here is to be replaced by 15 since we are asked to find the value of Q. Yes, find the value of Q. Actually, this value right here is not to be replaced from here. It should be here, no? Okay, since P is equal to 15, you plug in the value of 15 from this equation, so it becomes 15 is equal to 3 over 4Q. Solving for Q from this equation, and this is how you do it. You just cross multiply 15 by 4, and this is the result. And then you divide both sides by Q, and the value of Q is 20. Okay? Next, we go to the third example, which is still under the direct linear variation, and this is about Hooke's law, which states that the stretch S in a spring balance is directly proportional to the applied weight denoted by small letter W. If the stretch S is initially 8 centimeters when the initial weight applied is 20 pounds, find the following. The constant of variation K, together with the equation of variation, and the weight needed for a stretch of 6 centimeters. Okay, so for our solution, again, we translate what is being stated here, which is stretch S in a spring balance is directly proportional to the applied weight W. So, by translation, using K, that is S is equal to KW. And from that equation, K is equal to what? S over W. And making use of this equation that is solved for K, we can compute for the value of the constant of variation using the initial values of the stretched and the weight applied. So initially, S is 8, while W or the weight applied is 20. Okay, you plug in these two values to this equation, we can solve for K. That is 8 over 20. Reduce the fraction 8 over 20 to its simplest form by dropping the greatest common factor of the two. If you said it's 4, yes, you are correct. So that the simplest form of this equation will become 2 over 5 as the value of K. And from that point, we can form the equation of variation. Again, we refer to the translated equation, that is S is equal to KW. So from here, we just replace K by its value, which is 2/5. So that the equation of variation becomes S equals 2/5 W. And for letter C, the required weight for a stretch of 6 centimeters. So using the equation of variations, so the weight is unknown, meaning S is to be replaced by its final value, which is 6. So from this equation, it becomes 6 is equal to 2/5 W. So you do the cross multiplication. So at this point, the equation becomes 30 is equal to 2W, and then divide both sides by 2. Therefore, your W will be 15. Okay, the required weight for a stretch of 6 centimeters is 15 pounds. Okay, so that is the answer to number 3. So these are the answers in number 3 from A to C. Next. This time, we now go to the next type of direct variation, and this is the square, the direct square variation. And let us consider this as the fourth example. Let us read. So if y varies directly as the square of x, and initially y is 27 when x is 3, find the following. Again, the constant of variation k, together with the equation of variation, and the final value of y when x is equal to 7. Okay, so let us translate this statement right here. Y varies directly as the square of x using k. And that is y is equal to kx squared. And from this equation, we solve for k. And k is what? Y. K is equal to y over x squared. So, ang nangyari dyan, yung kadikit ng k na x squared, iilalim sa y. So that k is to be isolated on one side. So that k is isolated on one side. Yan. Then using this transformed equation, we can find the value of k using the initial values of y and x. Yun. So y is 27 when x is 3. So substitute, plug in the value of y here and the value of x right here on the denominator. So that will give you 27 over 3 squared. And we know that when you simplify the right side from this equation, your k is 3. So this is the value of the constant of variation. And what about the equation of variation? Again, from this translated equation, replace k by its obtained value, and we know that is 3. Okay? So k is 3, therefore your equation of variation would be taken from this equation, but we replace k by 3. And this is the equation. And for letter C, the final value of y when x is 7. So making use of this equation from letter B, we replace x by its value, which is 7. that will give you 147 as the final value of y. Next, we go to the fifth example. If d is directly proportional to the square of t, and d is initially 64 when the initial value of t is 2, find the constant of variation k, the equation of variation, together with the value of d when t is equal to 1.2. Okay. Of course, we translate d is directly proportional to the square of t, making use of the constant of variation so that the translated equation would be what? D is equal to kt squared. And from that equation, we know that k is equal to d over t squared. And making use of this equation, we can solve for the value of k using the initial values of d and t. Yun. Okay, ipalit yung value ng d dito, ganun din sa t, ipalit dito. So that the equation becomes, the resulting expression on the right side from this equation would be 64 for d over t squared, which is 2 squared. And your k is 16. And then, going to letter B, forming the equation of variation, we just refer to this equation, but if we want to copy this, we replace k by its obtained value, and we know that k is 16. Okay? So this is equal to 16t squared. So this is the equation of variation. And finally, for letter C, what would be the final value of d when t is 1.2? So we plug in 1.2 here as the value of t. So d is now 16 times 1.2 squared. We know that 1.2 squared is 1.44 multiplied by 16. Therefore, your d is equal to 23.04. Okay. Next. Number 6, the surface area of a cube varies directly as the square of the length of its edge E. If the surface area of a cube is 294 centimeters squared, when the length of the edge is 7 centimeters, find the following: the constant of variation k, the equation of variation together with the final surface area if the final length of the edge is 4 centimeters. Okay. So translate this statement. The surface area A of a cube varies directly as the square of the length of each edge, denoted by small letter e. So again, making use of k, the symbol k for the constant of variation, the equation is A is equal to ke squared. And from here, k is equal to A over e squared. Using this equation, we can answer letter A, which is compute for the value of the constant of variation k. So here, together with this equation, we consider the initial values of surface area and the initial values of the edge, the length of the edge. A is 294 while E is 7. So 294 over 7 squared. You simplify this side right here so that your k is 6. The value of k is 6. Okay. Next. What is the equation of variation? Again, we go back to this translated equation and we replace k by its obtained value, which is 6. And the equation of variation would become A is equal to 6e squared. Next, letter C, the final surface area if the final edge is 4 centimeters. So using this equation, we can compute for the required surface area. So since E is 4, that would be A is equal to 6 times 4 squared, or 6 times 16, so you have 96 square centimeters. And this is your answer. Okay. I think that would be all for now. Uh, at this point, I'm about to give the activity for you to work on, which is in relation to this uh, lesson from this video that you have just watched. So for now, see you next time.